practical topic which we are going to discuss today is, NR-RACH, okay, procedure, okay, and after that we will be, uh, showcasing you the content of this course, okay, content of course, and we will be discussing, there will be open for a form for question and answers in the last 15 minutes. We will be sparing for that also, okay. So now, when I talk about, let's go ahead with the NR-RACH procedure. Okay. So what is this NR-RACH procedure? Okay. So first, again, we need to understand what is this RACH. Okay. And how it was happening in LTE technology, and what is the, you know, difference. Okay. Or the upgradation, right? What is the upgradation in your 5G? Right? So basically, RACH procedure is your random access channel procedure. Okay. So when I talk about random access, channel procedure, or you know, when you are powering on your UE, let's say you are powering on your UE. Okay. It will scan, some frequencies, and according to the PLMNs, PLMNs exist, okay, consist of your mobile country code plus mobile network code. Okay. So depending upon that, it will come to know that, okay, I have to scan these frequencies, and what is best for me, it will choose, some three best frequencies. And again, out of that, it will, go with one of the best, which is good for that particular UE. It will decode some downlink synchronization channels. Okay, downlink sync channels. Now, what is the downlink sync channels? It is coming from your G node B. This is your G node B or E node B. It is coming from your G node B, E node B, and UE is receiving that. Okay, like these are your PSS, your SSS, and your system information block, or in 5G we call it as remaining some RMSI values. Okay. So remaining system informations and all those things. Okay. So your UE will decode this. And why UE needs to decode this? Because UE needs to, why we are powering on your UE? Because you want to use your mobile, right? You need to use the services, you need to browse internet, you need to see a video in YouTube, or you need to do a video calling, right? And for that you need resources. And for that resources, you is first getting all the informations from the G node B, and then after getting all the information, you will be sending a request to G node B. Okay. Or when I talk about LT, to E node B. Okay. That uh, you know this is the first uplink message being sent from UE. Okay, asking for the resources. As simple as that. Okay, I got all the information from you, and now I need resources. Okay, so it will be sending out the RACH request. We have different scenarios for RACH. Okay, I'm not going into that part, that what are the scenarios. The basic scenario is like, you getting powered on. Okay, that is your initial initial access. Then we have, when I talk about handovers are happening, it is also one of the, RACH procedure is being happening at that point of time also, because it is changing the G node B now. Okay, now UE was first with this G node B, now it is going to connect with this G node B. Okay, so at that point of time also, UE needs to, connect, needs to have the RACH procedure. Okay, you will come to know why we need it. You can say that, oh, why I need it, I am already in a connected mode. Then what is the reason behind that? Okay, then we have some scenarios like, uh, like when I say handover scenarios, UE powered on. Okay, UE is already in a RRC connected mode, but not uplink synchronized. This is basically your uplink synchronization, right? This is the first message being sent from UE to G node B. Okay, so there are a number of reasons for that. Okay, so once UE sends that RACH procedure. Okay, now again, when I talk about RACH is also of two types. Okay, so one is your contention based RACH, okay, CBRA, and contention free RACH. Okay, now this is same in both LTE and 5G. Okay, now when you say contention based and contention free, there can be a question comes into your mind whenever handover is happening. I have told that there is RACH is going to happen when U is moving from one cell, like say G node B1 to now to G node B2, GNB2. Okay, U is moving from here to here. Okay, and it wants to connect with this guy. Okay, you can say that why we need this uh, you know handover RACH procedure, and this RACH procedure may impact the services, like you are a individual using YouTube video, okay, and you are moving, right? So in that scenario, how you will be having the RACH procedure? Okay, so for that reason, we have something called contention free random access procedure, and uh, because it is a connected mode. Okay, so whatever is happening in a connected mode, we will be having cfra, contention free, and whatever is not in connected mode, idle mode, or all other things, it will be cbra. Okay, so now to understand more out of this, we need to understand what is being sent in RACH message. Okay, that is being sent from UE to your E node B, G node B, right? What is being sent? So it is, as of now, we call it something like uplink grant. Okay, what does that mean? Uplink grant means, you know, um, that you is having some resources to send out the packets, to send out the message, whether it is control information, which is control information belongs to your signaling part, user plane informations belong to your packets part. So it is UP or CP. Okay, so it has the resources. Okay, resources in the form of resource blocks. So we have something called resource blocks also. Okay, so not going into that physical, format and all those things. Assuming that you are a bit aware, and if you are not aware, just try to understand that we are having something called resource blocks, which is, you know, which can acquire the data, the packets, or the informations to be sent from UE to G node B or G node B to UE. As simple as that. Okay, so now UE is sending that. Okay, whether it is UP or CP. Okay, it needs a uplink grant. Okay, what is this uplink grant? It is the resources. Okay, in the form of resource block. But as of now, I don't have anything. Okay, whenever I am powering on my UE, I don't have anything. Okay, that I don't know about uplink grant and all that stuff. So what will happen? It will send the uplink synchronization message, RACH message, asking for that grant. Okay, so that it can ask for the request for the initial attach message. Okay, so it will send out the RACH, but for sending out that also we need resources, but UE doesn't have. Okay, so for that also how we will become, how we as a UE, how I'll be transmitting that. So I'll be transmitting basis on my downlink synchronization channels, or information, you can say system informations, which we have received in downlink before sending out the uplink message. Okay, so that system information is your SIBs, system information blocks. And for RACH procedure, we have different system information blocks. Okay, and when I talk about SIB, it will be having SIB1, okay, in 5G, which contains the parameters related to RACH. But when I talk about 4G, it will be SIB2. Okay, there is something called RACH common config. Okay, inside this SIB1, which will be telling me about the parameters related to RACH, um, like when to transmit this, what at what occasion I need to transmit, or what system frame number, or what subframe number. Okay, so that we need to understand. Okay, so again, system frame number, we have radio frames of 10 milliseconds. Okay, so that 10 milliseconds, it has numbering again, one radio frame, then next radio frame, then next radio frame. So this is numbered as 1 0 1 2. Okay, it goes till 0 to 1023. In total we have 1024 SFNs. So that is that I need to know at what SFN I can send this message, right? At what inside that I have subframes. Okay, even though I know system frame number, at what subframe I have to send, and in this subframe at what slot I have to send. Okay, so these all informations I'll be getting in SIB1 in 5G and SIB2 in 4G. Okay, we will go to those parameters. I have slides here. You can see these are the parameters for that. We will go and discuss about these parameters. Okay, so I am just touching the high level of uh, what is basically RACH and why we need RACH. This is the very basic question. If you don't understand this thing, then you will not be able to understand going ahead of going with the parameters and all. So basically you is sending this for the uplink synchronization first of all, and then I'll be getting a reply for that. Okay, and like this. Okay, now what is there, what information elements is there inside this RACH message? Okay, so basically I don't have any uplink grant. So what you will do, you will be picking up a signature, okay, or a preamble. We call it as preamble. Okay, it is kind of a signature, it is kind of a in sequence number kind of a thing. Okay, it will pick it up, it will generate first of all. Okay, using some parameters. We have three parameters again coming inside the SIB1 and SIB2. We have three parameters: zero config zone, okay, zero zone config or something like that, high speed flag, and route sequence indexes. Okay, based out of that, it will generate these 64 preambles are there with each PCI or each cell ID, you can say. Okay, so these are same in 4G as well as in 5G. Okay, 64 preambles it will generate, and then sorry, it will pick it up one and send this RACH. That's it. It will not have anything. Okay, it will send that, then we have something called ra-rnti also, that is radio network temporary identifier being given. Okay, and then it is your random access, RNTI. We have different RNTIs. Okay, that is being also being calculated. We have a formula, E node B, G node B knows about that, and it will calculate that according to the these subframe numbers and system frame numbers. In 4G we have sorry, 1 plus FID into 10 TID, something like that. So basically that give you a radio network temporary identifiers. Okay, so it will send out this information element. Okay, you will be sending out this to E node B, G node B. Okay, and using this any of the preamble, picking up any preamble. That is why we call it as random. Okay, so it will pick it up from 64, let's say let's say 62 or 27, anything it can pick it up and send this RACH message. But can you think of we have numerous number of mobiles getting powered on, or moving from here to there, handovers are happening. Okay, so in that scenario, if suppose my two UEs has taken 27 preamble and sending that out, okay, to E node B, what will happen? Both will get the rejection, or one can get the acceptance and get the reply from the E node B, G node B. But whenever you are in a handover scenario, can we do this? I am using the internet, I am using the YouTube, okay, as an individual, and at the back end, this is happening, right? So it will directly impact the service towards the customer. So for this reason, okay, out of this 64 preambles, we have kept some preambles for CFRA. Let's say 20 preambles and 40 for this, 44 for this. So for this reason, we have contention free, uh, random access procedure, and contention based is for your idle mode. because we can have some rejections in idle mode, but we cannot have rejections in contention free random access. Okay, so those 20 preambles, again G node B will tell to UE at the time of handover acknowledgement. There is a flow for that. At the time of that procedure, G node B, the target G node B will tell you use this preamble. I am having this preamble available with me. You use it, send me the reg, I'll reply you. I don't want to, play with the services what user is using. So for this reason, we will be having contention based versus contention free random access procedure. Okay. Now, when I talk about, you can see this is the flow and this is what I was explaining, contention based random access and contention free. So here you can see this is my G node B, this is my UE. Okay. And in contention free random access preamble assignment is being done. And after that, my message one, we call it as message one, random access preamble being sent. That is your PRACH, okay, physical random access channel. And I'll be getting a response, okay, a random access response. And then, you know, I'll be sending out the random access RRC connection request. Okay, then I'll be asking for the request for the RRC. Okay, with the establishment cause, that what is my reason to get into the attach or to asking for the, the resources. Then I'll be getting the, you know, the setup, the messages, contention, if there is any contention happening. What is contention now? That is the contention. I'm using 27. Other guy is also using 27 and sending it out to G node B. So how G node B will act? Either not give anything, any of the UE getting the access, and they have to go again, or one UE will be having the, message 2 and then message 3 being sent, and then contention is being happening. So this is what is your CBRA, contention based random access channel or procedure, you can say. Okay, and this is your contention free. I'll be getting a individual, you know preamble assignment. Then there is no reason of getting this contention over there. Now let's go with the the parameters. Okay, that what are the parameters we have in um, SIB1 or SIB2 of 4G. Okay, when I talk about the RACH related parameters. Okay, so basically you can see, just give me a second. Yeah, so you know yeah, I was not speaking. Yeah. So when I talk about SIB1, this is your SIB1 and of 5G. Okay. Inside that we have RACH config common setup. This is taken from a log only. Okay. Um, then we will be having something called patch config index, message one FDM. Okay. Message one frequency start. This is the parameter zero correlation zone config being used for generation of your preambles. Okay, this gives you a cyclic shift. Okay, NCS. According to that, we will be generating the preambles. Okay, which will give us the orthogonality between each preambles, and that is based out of your RSI and also. So that will also be there. Okay, root sequence index and all those things. Preamble receive target power. Okay, so let me explain one by one all these parameters and what is new with respect to 5G. Let me, give you an, idea that this is new. Okay, and this parameter is new and this parameter is new. Okay, in 5G, this is 5G related parameters, which is newly being introduced. Okay, so the only difference in 4G versus 5G, a RACH procedure is your message one. Okay, because in 5G now we have SSBs. Okay, and beams. Now UE has to select the best beam. based out of these SSBs, because again this will be having PSS and SSS, and here RSRP is based out of this in 5G. Let me tell you guys. Okay, there we will be having reference signals, right? So now the power which we are considering in 5G is based out of SSS. Okay, so we can have beams SSB beam sweeping also, right? Depends, one UE is getting the SSBs from different angles. So which one is best for this UE, it will select and then it will send out the patch depending upon that also. So those are differences between 4G and 5G. Okay, 4G we doesn't have those kind of a concept, so it will be very basic that we will be having the patch config index. Okay, this guy will tell about we have different preamble formats. Okay, so depending upon in 5G, depending upon the subcarrier spacing. Now, what is subcarrier spacing? We have different subcarrier spacing between the carriers. Okay, and if you are aware of the the grid. Okay, so we have 15 kilohertz of subcarrier spacing. Then we have 30, we have 60, we have 120 and 240. But in 4G, we have only one SES, that is your 15 kilohertz. Okay, so there are upgradations. That is what you need to first understand the 4G technology, then you will be able to understand the 5G one also. Okay, so now patch config index is something which will be telling you about the preamble format. Okay. Now we have different preamble formats, to tackle the noisy environment, to tackle the fading environment, all those things. Okay. So we have different preamble formats for that. Okay. In 4G as well as in 5G. It will tell about the preamble format to be used. It will tell about the system frame number. Okay. It will tell about the subframe number. Okay, so all these things it will tell about. Okay, so and the slot number also here. I'll show you one example going down the line in the slides. You will be able to understand. Then when I talk about message one, yeah. Anybody unmuted? No. Okay. I'll take up the questions in the last, guys. Okay, so then we have something called message one FDM. Okay, it tells about the number of patch transmission occasions, frequency division multiplex in one time instance. Okay, so up to 8 RACH occasion can be used in one time instance. I may be having this, yeah. So up to eight, RACH occasions, can be, can happen, can be used in one time instance. So what does that mean? This is your frequency, this is your time. Okay, and I have this parameter also, SSB per RACH occasion. Okay, so if you see over here, okay, so this is your frequency, this is your time. So SSB 0 is coming. Okay, RACH occasion 0 is happening. This is for the example of when I am having message 1 FDM is equals to 1 and SSB per RACH. That means per RACH occasion I'll be using one SSB. Okay, for another SSB RACH occasion 1 till 63. Again, going to another example, this you can see here it changes. SSB per RACH occasion is 2. Okay, so two times SSBs are using RACH occasion 0. SSB 63 RACH occasion these. Okay, so all these are like that. Another example we can look it off is message 1 FDM is 2. That is for that time instance 2 times RACH occasion for different SSBs. 2, 3, 62, 63, like this. Okay. So again, another is, SSB message one FDM is 2. SSB per RACH occasion is your, 1 by 1 half, 1 by 2. Okay. So in this, you can see SSB, RACH occasion keeps on increasing. So it will be going till 126, 127 for these SSBs. Okay, so am I audible to all? I got a message that no voice is coming.
Yes, you're audible.
Okay,
Yes, sir, you are able.
okay,
I can hear you clearly.
thank you. Yeah. So now another message is your when I talk about the next message is message one frequency start. Okay, so this basically refers to the offset, okay, of lowest patch transmission occasion in frequency domain. We have same message, okay, in 4G also. Okay, this tells, it is the zero physical resource block, PRB zero. From zero we can start the, patch occasions. Okay, same message we have in 4G, that is being named as frequency offset. Okay, then this is zeros, correlation zone config. Okay, there is a table from 3GPP. If it is giving a zero value, then cyclic shift will be given according to that. And from that cyclic shift and using, you know, the route sequence index also and high speed flag, we will be calculating the 64 preambles. Okay, and those 64 preambles are orthogonal to each other. Okay, so this is how UE is going to calculate using these three parameters, and these are same in 4G as well as in 5G. Okay, then we have preamble received transmit power. Okay, this is something, what G node B or E node B expects the preamble to to be received by this power, at least by this power. Beyond this it will not received. Okay, so this is the power. Okay, then we have preamble transmax. If by any reason you are sending your patch from UE to E node B or G node B, okay, you are sending the patch, okay, and you are not getting the response for that, the message too. Okay, I'll talk about what will be there in RACH, the message too. But as of now, just try to understand. I am sending a RACH and I am getting a response, but I am not getting the response in a predefined time. Okay, that time is RA response window size in the form of subframes 120. Okay, SF. So in this time, if I am not getting the response, at for how many times I can resend that patch using the same preamble. Okay, so that is the parameter preamble transmax n10. That means 10 times. But how? Same, it won't affect, right? If it is not reaching till E node B, you need to increase the power level, right, of your message, right? So for that, we have a power ramping step, that is DB4. So we will be increasing the power, okay, of that particular message being sent from UE every time it is getting filled. Okay, total number of RA preambles. Okay, these are for when I say, the contention based. So there is a, formula for that. Others are left for contention free and all those things are there. Okay, SSB per RACH occasion, and we have seen this part, and CB preambles per SSB. Okay, so basically this is your again, as this is having two folded beans, right? The one is SSB per RACH occasion. Okay, SSB per RACH occasion conveys the information about the number of SSBs mapped per RACH occasion, and CB preambles per SSB indicates number of contention based preambles available per SSB. Okay, to to more explain, we will have a again, if you have any questions, we will take up this two parameters, message one FDM and SSB per RACH occasion, in the last. Okay, I know there may be confusion, you have. Okay, so we will discuss. Okay, you can see I have given, the explanation. The meaning of this field is two-folded. Okay, it conveys the information about the number of SSB mapped per RACH occasion, and contention based preambles per SSB indicates the number of contention based preambles available per SSB. Okay, so we will discuss with an example. Okay, I have given the example also, but yes, we will take it up. Okay, in the last. Then we have, RA contention resolution timer. Again, when you are sending this message, there will be a timer being started in the cbra procedure, which is again in the form of SF16. So whatever your subframe is into that, it will convert into MS and everything like that. And till it receives it will, after that it will be receiving RAR, that is your random access response. It will send message 3 RRC connection request, okay, which will include the establishment cause, and it will be getting a contention resolution message 4. Okay, so if it is not happening in this period of a time, okay, it will start sending again with increased power. Okay, so this is the timeline which is being given for that. Okay, this is your patch route sequence index. Okay, that is being used to generate the preambles. Okay, it has been given as 91. Okay, then again, message one, this is also a new parameter. Okay, message one subcarrier spacing. Okay, so the subcarrier spacing for sending out the message one is 120 kilohertz. Okay, I'll correlate this with going forward down the slides. There is some calculations for having this system frame numbers or frame number slots on which patch occasion should happen. You know, because why we are doing all these things? Because UE doesn't have any grant as of now. Because of that, I am getting all these parameters in SIB1 in 5G and SIB2 in 4G. Three parameters which is being newly introduced is, let me mark it with different color. These are the three parameters which is being newly introduced. This one, then this one, and this one. These are the three newly introduced parameters with respect to 4G. And why we have this? Because now we have SSB concept and beam sweeping is there and all those things are there. Because of that, we have this message one have frequency division multiplexed and SSB per RACH occasion and contention based preambles per SSB and the subcarrier spacing. Okay, so these are the parameters which is basically being required for UE to send out a patch. Okay, because UE doesn't have any grant, any resource box sent by E node B or G node B that you send me the uplink synchronization on this resources. Okay, this is what I have explained, all those things. Okay, now for the purpose of slot numbering in the patch config index. So this is your patch config index, an example. Okay, patch config index number 75 has been given in my example, right? You can see this is the example, right? So according to that, I need to understand, right, that what is my system frame number? As I have already told that patch config index will tell you about the system frame number, preamble format, okay, then slot number, then what else? The starting symbol. You can see all those things, right? So from there, or subframe number, right? So this is how uh, I as a UE will try to understand that okay with the patch config index, this is as per 3GPP. This table is as just give me a second. We will be able to understand that this is my system frame number. Okay, then I'll be sending out the patch in which slot. Okay, that is your subframe. Then what preamble formats to be used. Okay, depending upon that I'll be sending out. But as per 3GPP, okay, as we do have lots of subcarrier spacing, okay, for message one, or even though normally also we have different subcarrier spacing. So what 3GPP has maintained two tables, one for FR1, another for FR2. For FR2, they have taken 60 kilohertz as base. For FR1, they have taken 15 kilohertz as a base. Okay. Now our case is 120 kilohertz, right? We have seen this over here, right? This is our case, right? Message one subcarrier spacing is 120 kilohertz, right? So according to this, this is for 60 kilohertz because it is FR2. right? So you can see Praj config index as 75. Preamble format we are using A3. Okay, we have different preamble formats. Okay, I may be able to show you in the Google or somewhere that we have different preamble formats for that. Then we have this is your SFN. So we have a formula for that: mod x is equals to y. So mod x mod 1 is equals to 0, and it will be coming as SFN mod x is equals to 0 indicates RACH can transmitted even in every SFN. If it is 1, it will be even. If it is 2, it will be odd. That means odd number of system frame number, it will be able to send the patch occasion. Or if it is even, so it will be like 0, 0th one, I'll be able to send the patch occasion. Okay, then 1 I'll be not able to. Okay, then 2 I'll be able to again send. 3 I'll not be able to. It will go till 1023, like this. So here we'll be calculating this that thing. Then the slot number, in which slot I'll be able to send out the patch occasion. According to 60 kilohertz, we'll be able to send it in 17, 19, 37 and 39. Slots in which RACH can be transmitted are 17, 19, 37 and 39. Since these slots number based on 60 kilohertz and subcarrier spacing for this example is 120 kilohertz, right? We need to calculate in which slot RACH will transmit and what is the starting symbol. Starting symbol is same, that is your 0. Okay. Then a number of patch slots within 60 kilohertz, again, that is 1. Number of patch slots that are available in 60 kilohertz slots, since this is we need to understand that this is 60 kilohertz, we need to calculate all those things. Number of time domain patch occasion within patch slot. Okay, so number of time domain, okay, within this patch slot. Okay, so that is 2, and its duration is patch duration is 6 OFDM symbols. Number of patch occasion available within the patch slot, that is 2 RACH occasions are possible within a slot. Okay, and this is your OFDM symbols which is being used. Patch duration in OFDM symbol is 6 OFDMA symbols. Now to understand this again more, you can see this. Okay, this is your a radio frame, but before that you can understand, we have 60 kilohertz slot, this is the one. And if we sit 120 kilohertz slot, we need to break it down, right? Because it keeps on slots keeps on becoming smaller. Okay, uh, in that particular area, when I talk about the grid, right? So it's 60 kilohertz, and when I see 120 kilohertz, it will become two slot. One slot become two slot. 240, it will become four slots, right? So like this. So when I talk about radio frame, this is my radio frame, you can see, right? What we were talking about: 17, 19, 37 and 39. But for 120 kilohertz, we need to send it out in 79, 75, 39 and 35. Okay, so in that area, we need to understand that how we are considering the 34th one or 35th one. Okay, so that we need to get calculated. Just give me a second, there is no formula over there in my slides. Okay, yeah. Okay, there is a formula to calculate this thing. Okay, there is a formula for that. L0. Let me showcase you. Decide, about that factor, like how we will be calculating that, in which slot it will be coming as. This you can see, L is equal to L, L0 plus NT then and duration of RA plus 14 N into RA slots. So you can see it is given the parameter starting symbol. Okay, we got it over there, the starting symbol, right? Then this NTRA is the press transmission occasion within the press slot number in increasing order from 0 to NTRA slot minus 1 within a RAD slot NTRA. Okay, if the RA, the subcarrier spacing is 139, it is fixed to 1. If fixed to 1 for LRA is equals to 839, and NTRA slot -1 when it is LRA is equals to 139. Now what is this LRA? We have this PRBs, right, in the grid. How much resource block it will be taking? First of all, okay, so it will be taking 6 resource blocks, and inside that, you know, we will be having um when I talk about 6 resource blocks into 12 into 72 and all those things, it will be coming as 1.08 megahertz. It will be taking this much of duration in frequency domain. Okay, but I don't need the subcarrier spacing of my these root sequences, okay, as 15 kilohertz. I can deal with 1.25 kilohertz also, because I just need to I just need to create an orthogonality. Okay, so for that reason I'll be using 1.25 kilohertz, and then I'll be coming up with 839 root sequence indexes, okay, the subcarriers, and there will be some guard band also, okay, using this total 1.08 megahertz. Okay, so this is how this will be calculated. But your NTRA slot will be fixed as 1 when it is 839, but when it is 139, that means this subcarrier spacing I am using bigger. Okay, it can be 5 kilohertz, okay, depending upon the subcarrier spacing also. Okay, so it can be depending upon the subcarrier spacing also, and the preamble format you are using in 5G. Okay, in 4G it was fixed to 1.25 kilohertz. Okay, so this is how this patch transmission occasion within the red slot is getting changed. Okay, then NRA duration, it is already given over here, 6 OFDM symbols, right? Then slot is also NRA slot is equals to 0 for you know 1.25, 5, 15 and 60 kilohertz. Okay, and for 30 and 120 kilohertz, okay, we have number of patch slots within a subframe, 2, or number of patch slots within 60 kilohertz slots. Okay, that means NRS slot is equals to 1, otherwise 0 or 1. Okay, so this is the formula which will calculate all those things, and according when we put all these things, we will come to a calculation of this. Okay, I have L is equals to 14 and 20, and according to that we will come to know that second slot is being used. Okay, like if we are using 35, 39, 37, 38, according to this um, diagram, we will be coming to a solution that the second slot is being used over here, because it was you know just give me a second. It was okay. So from here we will be coming to know. Okay, so that part that we will be using the second slots. Okay, so this is what we were trying to explain with respect to RACH procedure. Okay, there are lots of other things which may not be able to we may not be able to complete when I talk about in one session with respect to RACH. Okay, this is the base. That is what I have told, that we will be touching the base, that what is the difference between the NR RACH and the LT RACH procedure.